All right, here we go, guys. This is geometry areas of trapezoids, rhombi, rhombuses, and kites. And this is page 136 of your notes on 4/13 Monday. So areas of trapezoids. We can read through this, but there's your height, there's your two bases. You can do a glide reflection of the first trapezoid, which results in two congruent trapezoids that fit together to form a parallelogram. And you know a parallelogram is base times height. So we got to put together the two bases. So that's what we do in the formula here as I move down the page. So the area of a trapezoid is 1/2 the height times the sum of the two bases. Similar to a triangle in my view, but you have to add the two bases together. 1/2 base times height. In this case, we have two bases. So if we're doing real quickly, if we're doing two examples, here's the first example and then the second example. So I'm moving down the page here. First example, we have a handbag here with a base of 58 and 28 and a height of 30. To make that handbag, you wanted to try to figure out the area of it. Of course, it's not area, it's volume. But we would multiply 1/2 times the height, which is 30, times the sum of the two bases, and then you'd get a total of 1,290 square centimeters of that face of that handbag. Same thing with the face of a windshield. The windshield's 38 inches high, and then the bases are 72 inches and 85 inches. We're going to go 1/2 times the height times the sum of the two bases, which is 157. So you get a total of 2,983 square inches, and you know that area is square in nature, and there's your answer right there. And moving over to example 2, or the second idea of rhombuses and kites, and then example 3 and 4 and 5. I got 5. So here we go, areas of rhombi and kites. Recall that a rhombus is a parallelogram with all four congruent sides, and a kite is a quadrilateral with exactly two pairs of congruent sides, consecutive congruent sides. The areas of the rhombi and kites are then related to the lengths of their diagonals. And as you can see, the area of the rhombus and kite formula is 1/2 the diagonal times the other diagonal. So the diagonal that way, half of the product of those two. So again, rhombus and a kite, there's the diagonal, multiply the two diagonals together and take half. So our examples are, let me see if I can get both examples in. If we have a kite here and it's 1/2 times 8, that's that diagonal times 15, that diagonal, and you get 60 meters squared because it's dealing with meters. Whereas a rhombi here, I guess it's not a rhombi. Find the length of each diagonal, so you want to find that first. Since the diagonals of the rhombus bisect each other, the lengths of the diagonals are 12 plus 12 or 24 feet, and 10 plus 10 are 20 feet. So we're going to get 24 times 20. Multiply that and then divide by 2 or multiply by half, and you get 140 square feet. So if we take that knowledge into these two examples here, all right, we have a distance of 14 millimeters and 12 millimeters. So 14 times 12 divided by 2, or 1/2 times 14 times 12, 84 millimeters squared. There's your answer. That's how we get it. Remember, square in nature. In this case, they already give you the diagonals, 16 and 9. So multiply, take half of that, and you get 72 inches squared for your units. So in a nutshell, here is the formulas for each of these figures. So parallelogram drawn like that or drawn like that, it's base times height. Triangle drawn like that, there's your height from the top down to the bottom, or like this, base times the height is on the outside of the triangle, is 1/2 base times height. And then the trapezoid, you have two bases here, or if they look like this, whichever way they look like, the trapezoids can be a right angle or not a right angle, and 1/2 the height times the sum of the two bases. And whether that's a rhombus or a kite, the diagonals, we multiply them together, take half of the product of those two. So 1/2 times diameter 1 times diameter 2. There you have it in a nutshell. Areas of trapezoids, rhombi, and kites. Have fun.